Hello everyone, welcome to our teacher. I'm your physics teacher. Today we are going to deal about the introduction part or the topics or the main contents of the lesson electromagnetism. Okay, this lesson will be started with the scientist experiment known as Oersted. Okay, he is the scientist who discovered that there is a relation between two branches, electricity and magnetism. Before this discovery, it is believed that these two branches are separate branches. So he found he found a path, a discovery, and their discovery is nothing but our first experiment. In this experiment, we will find out that whenever there is a passage, let us suppose this is a conductor. This conductor, some amount of current is passing. So and that ammeter only shows deflection for current, but surprisingly what happened means he found out that a magnetic compass is being deflecting whenever there is a passage of current. There is a passage of electric current. So whenever the current is passing, the magnetic compass is being deflected, and there is whenever you shut down or shut off the passage of current, there is no deflection in magnetic compass. It means that he concluded that charge can produce another field known as magnetic field. So this magnetic field is responsible for the deflection in magnetic compass. Okay, so that is the fundamental experiment. Later we will deal about what is the kind of force acting on here is known as magnetic force, and we will deal about the concept of field, magnetic field. So magnetic field is nothing but the field in which magnetic substance, not a magnetic substance, a magnet can shows its influence, either attraction or repulsion, throughout its field, right? So that is known as magnetic compass or magnetic field actually. So the next one we will deal about the concept of how to detect the magnetic fields, detection of magnetic fields. Detecting magnetic field lines using compass. So we will find the magnetic field lines for a bar magnet. If you take a bar magnet like this, we'll come across these are field lines, and these field lines are being originating from North Pole and they're ending at South Pole. So this is the schematic diagram. Okay. Later we will deal about the concept of magnetic flux density. So magnetic flux density is represented by B simple. So magnetic flux density is the topic related to how much amount of magnetic field lines that are passing through a given sheet of paper. So if you feel these are some amount of field lines which are coming perpendicular to the paper, then we can take magnetic flux density B is equal to, these are called flux lines represented by symbol phi, and the area of this cross section area is phi by A. Or if there is certain angle between these two, we come across another formula, phi is equal to B bar dot A bar or BA cos theta. Okay, later we will come across how does the current is passing and the relation between current and magnetic field. All the concepts can be simply solved with one topic known as right hand thumb rule. Okay, or you can deal another topic if you not able to understand, known as screw rule, right hand screw rule. So this topic gives the relation between I mean, these two topics or any one of the topic will give the main topic or deals about how current and magnetic field directions are related to each other. If the current is passing like this in a conductor, then this is the field. Vice versa, that means if this is magnetic field, this is current. Why it is so, we will deal about these two. So depending upon these topics, we can crack many of subtopics. Later, the same concept, not the same one. For solenoid, we will deal about how the current is, how the solenoid is being converted or used as a bar magnet. So solenoid, this one is solenoid. Solenoid is nothing but a coil like structure. So whenever the current is passing from one of the ends to another end in a solenoid, this is the direction of current. We will take two rules using the loops. North one and this is south. This is the current direction, this is the current direction. Why this? How can we use these topics to the topic of solenoid? We will deal about that. And by using these topics, it will become much easier for us to talk about this topic is known as electromagnet. Okay, students, later we will discuss about two forces. First of all, we will discuss about what is the force acting on a charge. And the force acting on charge is nothing but F is equal to QVB sin theta. And how does the formula came? We will deal that. And this is known as magnetic force actually. Magnetic force. And how the force is acting on a current carrying conductor. Force acting on a current carrying conductor. For this, we will use Fleming's right hand rule for electric motor and left hand, Fleming's right hand rule for electric generator and Fleming's left hand rule for electric motor. So to know the direction of the force acting, we will simply use in the most of the cases Fleming's right hand rule. So in the Fleming's right hand rule, it is very important and easy. This is the direction of force which is acting on a conductor, and this is the magnetic field, and this is the direction of either current or charge. Okay, I hope it's clear. So the next one we will deal about, after completing these topics, we will deal about a topic known as Faraday's law of electromagnetism. Faraday's law of electromagnetism. This topic deals about what is the relation between flux linkage and EMF is induced in the coil, EMF induction in the coil. And in the subtopic of this, or as a subtopic, we will deal here known as Lenz's law. So this law basically deals about how does the effect is opposing its cause. So by clubbing or by integrating these two topics, we will deal about the final formula E is equal to minus n delta phi by delta t. So here n is nothing but number of turns. Delta phi by delta t is known as rate of change of flux linkage, and it is nothing but EMF production in a coil. And here minus n is representing the EMF is induced in a opposite direction. Okay. As the concluding topics of the lesson, these are also important topics. We will deal about what is meant by electric motor. Simply, an electric motor is a device. It is a device which can convert any kind of energy, finally into mechanical energy. Okay, so electric motor concept we will use here, and similarly what is meant by electric generator concept? Electric generator is nothing but reverse of this. It is a device which converts any energy, any format of energy into electrical energy. In most of the cases, this any energy could be replaced by the name of electrical energy, and here most of the cases any energy is nothing but mechanical energy. So that is the topic. In this we will deal about three topics. First one is electric motor. So in the electric motor, simply we will take an armature or a coil which is like this, and this coil will be set up in external electric field, external magnetic field. So this is the magnetic field lines. So here we will send certain amount of current in the coil. A is the current passing like this electric motor, and we will see how does, and it will be rotated this way. These are the forces which are acting on the coil. So hence the coil will be rotated like this. And how does these forces are acting? Everything will be disclosed in the topic of electric motor. And finally we will deal about generators, electric generators. So in an electric generator, a diagram is there. In your textbook you can follow them. The output will be this is the output known as AC output. AC means alternating output. AC means AC current, that means alternating current. Alternating current. And this AC current we have, if you see here, this is known as cycle. From here to here it is called one cycle. We have two sub cycles here. First is a positive cycle and second one is a negative cycle. By using the commutator slip and commutator as well as slip rings, you can either convert, you can convert this one a lower pulse into a upper pulse. So the diagram in a commutator if you use will be like this. First will be the same, second you will get the like this, third one is same, fourth again you will get like this. The purpose of converting like this is we will converting an AC signal into, or AC electric power or AC current or voltage into a DC one. So these are the topics that will be disclosed in this lesson. Thank you.